In this video, we're going to focus on the concentration unit of molality. Molality is moles of solute per kilogram of solvent. So I've got basically two mass-based units here. And so this image here shows the difference. And in this one, this is a capital M here. So the capital M means molarity, versus this one is a lowercase m, is molality. And so the difference in the two words is the I versus the R. Let me write this a little bit. This is M-O-L-A-R-I-T-Y. So there's the R, okay? And we talked about that one earlier. And when I look at these two images here, they look like they're the same, but they're not. Okay, so I'm adding 1 mole of glucose, which happens to equal 180 grams, and I add that. And you notice that I don't have any mass unit of volume. Instead, I have a 1 liter mark, and so I add water until the volume comes up to be 1 liter, and I get a 1 molar solution of glucose. This side, I add still 180 grams, but now I'm adding 1 kilogram of water to this, okay? And here's my 1 liter mark, and the water is actually slightly higher than that. So this has a volume greater than 1 liter as a whole. So they are not the same, okay? Now, let's do some problems here, okay? And this problem, it wants me to calculate the molality. So molality is what I want to know. If I have a mass of 5.50 grams of NaBr, and I have a mass of 78.2 grams of solution. Now, I want to point out that in general, the solution is always made up of two things. So the solution is the solute, which in this case is NaBr, plus the solvent, which it doesn't state, but we're going to assume it's water unless it tells you something different. We're going to assume it's water. And so I can say that the mass of solution is equal to the mass of solute plus the mass of solvent. And I need this equation here to do this. Okay, so molality is going to be the moles of NaBr over kilograms of water. Okay, so before I can plug into this equation, I need to know what the moles of NaBr are. And so moles of NaBr is going to be the mass divided by the molar mass. So the molar mass of NaBr, I give you the individual. When you add those two together, you get 102.89 grams per mole. So my moles of NaBr is going to be the 5.50, which was given. It's right here. Grams divided by the 102.89 grams per mole I just calculated. And I get 0.05346. And that's moles of NaBr. Okay, now I have mass of solution here, and I just need mass of water. So I'm going to go back to this equation here, okay, to find that. So I have 78.2 grams. I have 5.50 grams as my solute, and the mass of water is what I don't know. So 78.2 minus 5.50. I don't have this number quite right. Let's see. It's going to be 72.7. Yeah. Grams of water, which is 0.072 0.2727 kilograms of water. I'm dividing by 1,000, or I'm moving the decimal place 3 to the left, however you want to remember it. So then my molality, which I'm going to write out because of the capital M versus lowercase m is very difficult to distinguish, is going to be the moles, which I calculated to be 0.05346 divided by the kilograms of 0.0727. And I did not do this right when I did it. It had it written down. So I gotta get my calculator out. Okay. All right, so 0.05346 divided by 0.0727. And I get, from that, I get 0.735, and it's with a capital M. Okay. All right, next slide. This one is also a molality problem. You're going to be responsible for knowing that this right here means molality. And somebody will ask me on the test, and I will not be able to answer the question that means the small m means molality, because when it's typed, you can tell. Okay. All right, so this problem wants to know what the mass of H2O is if I have a mass of NaCl is 100 grams. All right, it's NaCl twice. All right, and again, the formula for molality is going to be the moles. This time my solute is NaCl, so I'm specific here, over kilograms of water. Okay, so I need to find the moles of NaCl first. So the N of NaCl is going to be the mass divided by the molar mass. So before I do that, I need to find the molar mass of NaCl, which I just add these two together. And when I do that, I get 58.44 grams per mole. So my N of NaCl is the mass that was given, which is 100, divided by 58.44, and that gives me 1.711 moles. Okay, now I'm going to plug into this formula. I was given the molality. The molality is 1.50. I just calculated the moles as 1.711. And what I don't know is my water. When my unknown is on the bottom, I'm going to multiply both sides. So I have 1.50 times kilograms of water is 1.711. So my kilograms of water is going to be 1.711 divided by 1.50. And that gives me 1.14 kilograms of water. It didn't specify it had to be in grams, so I can leave it here, as this is my mass of water. And that is going to be the end of this video.